Hey there, I recognize that this is a really challenging activity that I had to do, so I'm making a video just showing you how to do the answers so you can kind of check yourself a little bit. So we have factored form, vertex form, and standard form, and they each kind of tell us something different. So I automatically know that my y-intercept is 1, so I'm going to go ahead and plot that right there, and then I'm going to try and factor this thing. And we get x squared and 1, but when I factor it, I have to get something to add up to 4x that multiplies to 1, and there's no such thing. So we can either do, so this step doesn't work, right? You can't factor it. So another alternative is to convert it into vertex form, or use the quadratic formula to find the roots. And I'm gonna convert it to vertex form. So we got y equals x squared plus 4x plus 1. And remember, we take that b, the b value is 4, we cut it in half, so 2, and then we square it again, which gets us back to 4, but that's okay, because we're going to add and subtract that. So we get y equals x squared plus 4x. We're going to move that plus 1. We're going to add 4 and subtract 4. This is our perfect square, so x plus 2 squared, and then this is minus 3. So our vertex form is x plus 2 squared minus 3, which tells us actually that our vertex is -2, -3. So -2, -3. So we kind of we're starting to get an idea of where these things are going. And if I want to find the roots, that's when the y value, the height on the x-axis, the height of every point on this x-axis is 0. So we're going to set this equation to 0, and we're going to solve. So 0 equals x plus 2 quantity squared minus 3. And that's going to require us to do some steps to solve this thing. So plus 3, so 3 equals x plus 2 quantity squared. And we've got to take the square root of both sides, but that means we get plus and minus. So we get plus and minus the square root of 3 equals x plus 2, and to finish that off, we're going to subtract 2, minus 2, so -2 plus or minus the square root of 3 is equal to x. And if I use a calculator, -2 plus the square root of 3 ends up being -0.267, and then the other option, so x equals that, or -2 minus the square root of 3. Find my square root button, square root of 3, we get, or x equals -3.732. And that's a good thing, right? Because when we come back to our equation up here, we're looking for opportunities to plot those. So we have -2.5, and my graph switched on me just a little bit. Sorry about that. So one of them is negative a half, or -1/4, which seems about right, and the other one is -3, and some, -3.7, so 3 3/4-ish. Well, now you can start to see that this parabola can start forming if we go through each of the points. And it's not, the graphs are never going to be perfect, but I hope that you can see that if it's not factorable, we've got some options, and one of those is to find vertex form. In the second one, we're going to kind of do a slightly different approach. We're going to still try and factor it, so x squared and 4, and we're looking for two values of x that add up to 5x, but multiply to 4, because this diagonal is x squared times x, and that ends up being 4x and 1x, which is nice because then it's factorable. I can pull out the values that I need to. So the factored form of this is x plus 1 times x plus 4. And so here, right off the bat, I get my y-intercept. My y-intercept is 4. 1, 2, 3, 4. I'm going to plot my y-intercept. And if I set these equal to 0, that means that x plus 1 equals 0, or because we're using the zero product property, or x plus 4 equals 0, which means that x is equal to -1. Okay, so I'll plot -1, or subtract 4, x equals -4. Okay, so -1 or -4. And my vertex should hopefully be somewhere in between. I'm going to use the quadratic formula this time. So x equals -b plus or minus the square root of b squared minus 4ac, all of that over 2a. Actually, I'm going to use the vertex form that I talked about in one of my videos, that the y value, the x value, is going to be -b over 2a. And the b value is, in this case, is 5. So -5 over 2 times a, which is 1. That's -5 over 2, which is -2.5. -2.5, and that means that it's going to happen somewhere on this vertex line, right? This is the line of symmetry, is where my vertex is going to occur, and I've got to plug that value into either this or this. So we're going to plug it into y equals 2.5, -2.5 squared, plus 5 times -2.5 plus 4. And I'm going to use my calculator because I don't want to do this by hand. Times 2.5, -2.5 squared is positive 6.25, and 5 times -2.5 is -12.5, and plus 4, so 6.25 minus 12.5 plus 4 is -2.5, and it tells us that the y value is -2.5. So -2.5 is right there. And you can see that this actually kind of makes it this perfect parabola when you go to graph it. So you're using all of these tools to your advantage here. All right, in this one I recommended using the quadratic formula, but we've already got our our y-intercept, and so we're going to go down, we're going to go by twos, 2, 4, 6, 8, 10, 12, 14, this is 16, so if they go by twos, 15 is right between, 14 and 16, and so we've got our -15 right there, and I recommended using the quadratic formula, so x equals -b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. And we're just going to replace values, so -12, it's a positive 12, but it says -b, it's the opposite of 12, plus or minus the square root of 12 squared minus 4 times a, which is -2, times c, -15. We're going to honor the values in between them, all over 2 times a, which is -2. So we get, and I'm just simplifying, 144, and then -4 times -2 times -15 ends up being -120, all over -4. And we've got to honor that this is a -4, this is a -2, and this is a -15 when we're calculating that value there. Because it matters, it really does. Otherwise you're going to get something that's not true at all. So x equals -12 plus or minus the square root of 24 over -4. And this can split off. So x equals -12 plus the square root of 24 over -4, and x equals -12 minus square root of 24 over -4. I'm going to pause the video to do the calculations. And like movie magic, we're done. So we're going to plot these. These are our x-intercepts. And I'm going to zoom in just a smidge. We got 1.775, which is not quite 2. So we've got to be really precise here. And 4.225, which is almost 4 1/4. So 4 and a smidge. 4 and a little bit. That's 3 and a little bit. Here, we got to go back. And got to go back. Okay, so 4 and a smidge. 1, 2, 3, 4 and a little bit. Oop, that's right there. 4 and a little bit is right there. And now we've got to find our line of symmetry. And to find our line of symmetry, we have to use this formula, and you could do the vertex form on this, but because of this 2 in front, it really makes it really challenging. So the line of symmetry, this formula, negative b over 2a, is derived once you understand calculus. Since we're not going to go into calculus right now, you're going to have to just trust that this gives us our line of symmetry. And the line of symmetry is negative b, which is negative 12, over 2a, or 2 times negative 2, which is negative 12 over negative 4, which ends up being 3, which is a very nice number to be working with, because you can see that our line of symmetry is in fact perfectly in between the roots. And we're going to find the point at which the height now. So if I know the x value of the vertex, I can plug in the x value into the original, I can plug in this x value into the original equation to find the y value. So the y value at the vertex point is what happens when I plug in this green 3. So negative 2x squared, or 3 squared, plus 12 times 3 minus 15, I put it into a calculator, I get 3. Oh my goodness, what is that 3? That's the height. That means that on that line of symmetry, I'm going to count 1, 2, 3. Actually, since these are going by 2s, it's 1, 2, 3. I have to remember that each line here is, this is 2, this is 4, so 3 is right in between there. So there's where our 3 is, and we start to get this nice curve that goes through all of the points. Okay, and this happened to turn upside down on us, and that's okay, right? It's still a parabola. It still has that U parabola shape, and it's going through all of my points. That's really good. So thanks for sticking around with me. I hope this video was informative. I don't know if it was, but thanks for watching.